So welcome back. In this video, I'm going to be trying out an operating system that actually doesn't have a name. It is referred to as Untitled OS. It's a 32-bit operating system, and from the description we see this is a completely monolithic OS with a single user space API for everything. All an application needs to do is include it. Basically, this is a very, very minimal operating system. I actually checked using a lines of code counter, and the kernel itself is only about 5,000 lines of code, and yet, supposedly, this is featureful enough that it supports graphics and can actually run Doom. So, I'm very excited to check this out. Let's get into it. Alright, welcome back to Virt Manager, everybody. Today we have an operating system that I am very excited for. Let's create the virtual machine for the Untitled operating system. So here we have it, Untitled x86 OS ISO. And we'll put it on generic. Now, this operating system does not support SMP, so we will only give it one CPU because it cannot use more than that. We will give it a, let's say, 15 gigabyte disk, and we will call it Untitled OS. There we go. We've created it. Now let's boot it. Wow, that was a very fast boot, I have to say. I'm just trying to move my cursor diagonally, and it is stuttering a bit. This kind of reminds me of buggy trackpad drivers, perhaps on Linux. There's also this little blinking square in the top. I think every time I move my mouse by 1 pixel, it actually changes. But let's get into the actual OS. So we do have a Windows system, and behind that Windows system, we have the command line. So I was actually wrong. This is not a command line. This is a log. And as we can see, the system time actually only updates whenever I force it to process some kind of event. It is using only about 2 megabytes of memory, so that's very good. I mean, I suppose if it was more, I would be quite surprised, because it is an operating system it's an operating system kernel of about 5,000 lines of code. Let's open the file browser again. So yeah, as you can see, there's a little button for that. These are the programs that exist on it. I suppose if I open them, they will show up, yes, as Windows. So yes, this is an actual windowing operating system. You cannot really resize anything, so that is a bit of a shame. I think it would be really nice if you could resize them, but I suppose not. The first thing we're going to do in the terminal, let's see what... it does not handle backspaces correctly, and it does not have callback support, so I guess I will have to type slowly in QWERTY. Wow, it doesn't even handle enter. Let's try again. Help. That's very strange. See, here I'm typing backspace and enter to try to get the terminal to process my command, but whenever I press enter, it just does this. Let's see if we can find anything about that in the documentation. So there is unfortunately no documentation about the terminal. Let's continue exploring the GitHub repository to see if we can find something. So I've just pulled up the source code for the terminal program here within the GitHub repository. So let's see if this even really implements anything. Alright, so that's interesting. Just from a cursory glance over at this, there is some kind of operating system event management. However, if we get a key event, which happens whenever I type, supposedly, all it does is it casts it to a keyboard event, and then it types that character out into the terminal, which is why whenever I type here in the terminal, all it does, it's literally just taking the keys and trying to put their ASCII value into the text buffer, which is why enter and backspace are giving these weird things. Based on this code, it seems that the logic for entering text into the terminal is implemented, however, nothing else is. So actually, this is not even a functional terminal. You really can't do anything with it. But the next thing I want to see, and don't worry, we will get to Doom, because this operating system is meant to run Doom. Let's try Breakout. So this is a much more, I suppose, featured program. It actually works. Well, maybe I was being a bit generous. It even handles accelerating the little dot. Alright, so that's a pretty primitive breakout implementation, but I suppose it works. Let's try the timer. That doesn't really do anything. That's a test program. Did I accidentally open the wrong one? No. See, I clicked on timer.exe, and it is just a test 2. Let's try test.text. Oh wow, there's a text editor in this. However, once again, it is similar to the terminal, I suppose, because I cannot really do anything. See, when I press enter, when I press backspace, this is a very primitive text editor. It would be generous to really even call it a text editor at all, to be completely honest. Files.exe is the same thing here. Next, what is it? There's a draw.exe. So this is some kind of paint program. Oh wow. It is just picking a random color, or perhaps it is a deterministic sequence of colors based on what tick update it is, as you see here in the sys_time. But let's try drawing something with this. So that's really as good as I'm going to get at a smiley face. Actually, let's give him pupils. Yeah, I can't say that's my finest work, but I don't really know if you can tell. I'm actually not clicking here. It's whenever I move my mouse. See, clicking doesn't really do anything. So you actually cannot stop drawing, and it's very, very laggy. It's still interesting that you can do this, and I have never seen a paint program quite like this. Let's try tasks.exe. So this is some kind of task manager. Let's try to open more programs. Oh, as you can see, it has updated. It gave it a new ID. So there are 3 processes running. Actually, I don't really know what each of them correspond to. My guess would be that 1000 is actually the kernel, and then 1001 is this this sort of shell we have here. I'm really trying to move my mouse around, but it's struggling quite a lot. But finally, let's get to the moment that we've all been waiting for. Let's try to run Doom on this thing. So my arrow keys actually do not work. That is, oh, well, WASD works. You know what? We're playing on something that I assume is going to be very difficult to control. So let's put it on Hey Not Too Rough. Alright, no, so it does detect the arrow keys, and unfortunately, I can only use the arrow keys to look around. The mouse does not really do much. I actually can't even shoot. I cannot rebind it, and I'm not sure if you noticed, but there is no sound, so this operating system does not implement sound. Again, it makes sense. You know, sound hardware is one of those things you really don't want to deal with unless you absolutely have to. So I guess this operating system developer just decided that they did not have to. I could have sworn there's meant to be a button here. Now I'm gonna have to just run past these guys because, as I've already explained, I cannot attack them. I would sprint here if I could, however that also unfortunately does not seem like an option for me. I see, we have beaten E1M1 Doom on the untitled x86 operating system. Let's try E1M2. This level is not much harder, so I do not anticipate that I will struggle. Let's go get the chainsaw. No, it wasn't the chainsaw, it was the minigun. My bad, I have not played Doom in a little bit of time. I'm very happy to have the minigun, however, that doesn't really mean much to me because I cannot attack. Because this game does not register mouse events. Indeed, that's why I'm having to look around using the arrow keys rather than using my mouse, which I would much prefer to do. You know what, let's try E1M3 and then I think I'm really gonna wrap this up. Still, this is very interesting so far. The fact that this is, you know, only 5,000 lines of code, and it is a, you know, for what it is a surprisingly well-featured and interesting operating system. Again, the way the shell is done, I don't think I've seen something quite like it before. No. Alright, run. Alright, that is E1M3. If I could actually shoot or really attack, then I would probably continue playing. I would at least try to beat E1. I find interesting that the physical memory used is continually increasing, even though we are actually closing a lot of the programs that we have opened. So perhaps there are memory leaks in this kernel. Perhaps it is just because it's using memory to, you know, store the history of the logs, although I don't really know why you'd want to do that. Probably you'd really want to, you know, dump this data through the COM port or something like that. You wouldn't really want to actually save it in memory. Yeah, I do find that interesting. Perhaps there's a memory leak in this kernel. So yeah, that's the Untitled operating system. Very, very interesting operating system. Very primitive, but I'm very happy for whoever made it, because it really provides this sort of interesting glance at what you can make with very, very little code. This is a extremely minimal operating system, and it has, you know, it has a shell, it has a kernel, it has these, you know, it has Windows, it has a bunch of programs on it. yeah, I suppose that's that. Thank you for watching my video. If you enjoyed it as much as I enjoyed playing around with this operating system, please leave a like, perhaps even subscribe. I think in the future I will do more of these from scratch operating systems because I really like them. They're super unique. I certainly like Linux distros as well, but there's something just very charming about a from scratch operating system that doesn't have a lot of features, but what it does have, it does it with charm, you know? This operating system was an absolute joy to just mess around with, to see the sort of quaint simplicity of it, and yeah, that's pretty much it. Thanks for watching.